I'm Paul from team A-Comosus, and I'll be giving you an overview of our project and team. I'll briefly explain our tech stack, workflow, branching strategy, and the key features of our project. I'm sure you've all heard of Linktree, which provides a platform for users to create digital identities for their social properties and connect to their audience through a single link. Our team focused on reproducing the platform as a proof of concept with the tech stack that we would like to explore. The aim of this project is to learn new technologies and understand the tools and process that underpin the practical aspects of software development. For the backend, we use Next framework to build a GraphQL server. We use the Prisma ORM to interact with the MongoDB database. And we also implemented JWT authentication with possible JavaScript. For the front end, we use the Next JavaScript framework to build our client-side application. Chakra UI and Framer Motion were implemented in our UI layer to bootstrap the development process. We've also introduced Storybook in our project to manage our UI components. Most of the state management is via React Context API, but we are planning to implement Rustin as our state manager in the coming weeks. To ensure the stability of a project, we'll be taking the testing trophy approach and fulfilling our testing solution using Cypress and React testing library. Leveraging the benefits of serverless functions, we have used the serverless framework to set up the development environment of our AWS Lambda functions, offloaded the process to send email correspondence, process and upload user avatar, and resolve multiple asynchronous API calls to the third-party platform. Then there's also the React hook form for form validation, React query to fetch and cache API responses, React I8 Next and Next JavaScript's internationalized routing for localization, and GraphQL codegen to generate type-safe GraphQL query and mutation hooks. In our team, we have 5 developers, 5 devs, 1 UI, and 2 BA. We followed the Agile software development lifecycle using Jira to plan and track our progress. Once an issue on the Jira board is assigned, the assignee will create a feature branch from the develop branch, push commits, and open up a pull request while filling a checklist of our pull request template. To control our code quality, we've also implemented GitHub Action to act as our gateway for this solution. When a pull request is open, GitHub Action will automatically run linter check unit tests before attempting to build the application. When the reviewer approves the pull request and conversations will resolve, the feature branch gets merged into the feature branch gets merged into the develop branch, which targets our UAT environment. And finally, when the features are tested, we will then merge the main branch, which targets the production environment. To quickly explain our core feature, referencing Linktree, the user will first start creating an empty link on the profile. When the user enters the URL they want to share, the URL will be sent to our backend server, which will run through a third-party API called jracademy-ade to validate if the URL is reachable. Once it's validated, jracademy-ade will help us extract the metadata from this URL and populate the title with its page title. Then we attempt to resolve the type of this URL, whether it's a video, Pinterest, or a generic link, and designate it with the corresponding type in the database. Once the mutation is finished, the front end will invalidate the query cache and fetch a new copy of the profile items, rendering the corresponding variants of the UI component given its type. To utilize the full potential of Next JavaScript's data fetching and pre-rendering features, we have implemented our project page with static site generation. Next server will pre-render the page by fetching the information through our Lambda function. Then it will generate the static page that can be served almost instantaneously on user requests. Public profile pages were implemented with server-side rendering instead to shift the workload of clients while ensuring data is always up to date. We have also integrated a Web3 and NFT minter into our project. Users can connect to their MetaMask accounts and send transactions to a smart contract on the Goerli Ethereum testnet to mint image tokens that are randomly generated from an image engine. These tokens can be used as avatar or background. Users will also be able to view or trade their tokens on OpenSea. And that's the high-level overview we want to share from the developer perspective. And Alex and Kelvin will show you our project architecture.
Hi, everyone. This is Alex. I will illustrate the project architecture in production environment. Kelvin will present the project architecture in UAT environment. This is our production architecture diagram. To keep the benefit of CDN network and the functionality of server-side rendering, we deploy our frontend in Lambda Edge. User will be directed to the closest CDN to access our frontend. The static content was cached at AWS CloudFront. Server-side rendering pages were compiled by the Lambda Edge function in the CDN server. To enable the encrypted connection, we use the SSL certification from the AWS Certification Manager. To achieve the high availability and scalability and reduce the difficulty of cloud migration, we deployed our backend on the EKS. The backend node was deployed on the private subnet to ensure the security. As the private subnet does not have the internet access outside the VPC, we deployed the NAT gateway to allow the backend pool to pull the image from DCR and access other third-party services. The NAT gateway will ensure the backend application has a secured communication with the internet. The user will connect to the backend port through the application load balancer. The user requests will be distributed by load balancer across two availability zones. The Kubernetes horizontal autoscaling and the AWS EKS cluster autoscaler ensure that the backend could handle large request traffic. We deploy the API gateway and Lambda function to process and store user avatar in S3, handling email communication and resolve multiple asynchronous data fetching operations. The connection between the backend and the API gateway is also secured by the SSL certifications. For the data storage, we choose the MongoDB Atlas as our application database. All of the cloud infrastructure was deployed through the Terraform to achieve efficiency and consistency. Now I will introduce Kelvin to present the project architecture in UAT environments.
The following graph shows the project architecture in the UAT environment. We deployed our applications in two availability zones within the Sydney region and used MongoDB Atlas as our database. The incoming traffic will be distributed by the application load balancer across these two availability zones. Meanwhile, it collects the access log and stores it in a private S3 bucket. The access log contains information such as the latencies, request paths, and service responses, which is critical for us to analyze the behavior of the application in the current environment and minimize the occurrence of failure in the production environment. Both the front end and the back end are deployed in separate ECS clusters within private subnets, and all outgoing traffic will go through the NAT gateway to fulfill the security practice. I'll hand back to Alex for now.
We choose the GitHub Action as the CI/CD pipeline tool for the production environment. After we validate the application in UAT environment, we will trigger the production CI/CD pipeline manually. For the backend, GitHub Action will run the static type checking and automated testing. After that, it will build the Docker image and upload it to the production ECR. Then the pipeline will use Terraform to update the backend image in EKS. The frontend pipeline is similar to the backend. The difference is that after testing, the pipeline will use the serverless Next.js framework to update the Lambda Edge function and the static content in CloudFront. Next slide, please. The EKS cluster monitoring was handled by the Prometheus daemon set. It will collect and store the cluster resource metrics. Then we utilize the Grafana to visualize the cluster. Then we use Grafana to visualize the cluster CPU, memory, and storage usage. This is the screenshot of our Grafana dashboard. Next slide, please. The cluster logs was collected by the Firebase daemon set. The Logstash, Elasticsearch, and Kibana are responsible for filtering and presenting the application log. That concludes our presentation. Thanks for your listening. Now we move to the Q&A part.